All right. So we look at the derivation of the lens equation now, and it's basically worked out by using the following convention. We have a biconvex lens, and it's a f of dashed to C1. Now we'll start with an object, a certain height. We will see how the image of this object forms on the other side. So that ray is going to refract, pass through the focus, another ray of light which is going to pass through the optical center, pass undeviated, and we will be obtaining an inverted image of the object. So this is the object O, and this is the image I. We will give some labels for all of these points. So let's call this A, B, point C, and we will call this PC. Change this. Let this be C, let this be D, and let this be E. So A, B, C, D, and E. Okay. Now the derivation begins with these two triangles. Okay. Which is triangle BEC and triangle CID. So we need to label a few more things over here. This distance over here is what is known as the object distance. There are two more points. This distance over here is of course the focal length, and this distance is the distance of the image. Okay. Now if you consider these two triangles, what you can immediately see is these two triangles are similar triangles because they share one angle. It's a common, it's a 90-degree, so therefore this angle should also be the same as that angle. So these are similar triangles. Okay, it's a slight shape. Okay. And since these two triangles are similar triangles, we can now say that the ratio BE, no, we'll keep ID to BE is going to be the same as the ratio CI upon CE. And this ID and BE actually are the heights of the image and the height of the object. Okay, so I can therefore say this is the same as writing height of image by height of object is the same as Ci. So Ci can be written as Di minus F, right? Di minus F is this, that is Ci. And height of object, Ce is nothing but F. Okay, so this is the first part of the equation. So let's keep this as the result, this part of over here, and we'll move on to the next set. The next set involves these two triangles, that is this triangle. I will use a different kind of hatching now. And this triangle, okay, that is triangle AOE and triangle ECF. Well, these two triangles are also similar triangles for the same reason. There is an these two angles are the same. There is a right angle, so therefore this angle and this angle is also the same. So these are also similar triangles. So therefore, again, I can write the ratio in terms of these. Okay, for the same thing, I can write. I have to take this entire triangle. Sorry, EID. EID. This entire triangle. So there again, HI upon HO, HI upon HO will be equal to the ratio between EI and OE, okay, which can then be written as EI is DI and OE is DO. So now I have two results over here which are the same, HI by HO equal. So therefore I can make the RHS equal to RHS, and I can write it as di by do is equal to di minus f divided by, and this is a very important result. This result, if you simplify it, you will get the length equation, which can be written as 1 by f will be equal to 1 by di plus 1 by do. I would like you to convert this into this, prove that this is equal to that, and then you will have your length equation.